Well, hello, everybody. Thank you for joining us today. This is the North Central Climate Collaborative every other monthly webinar. Today, we are going to focus on some specialty crop decision-making during drought. By way of logistics, the chat feature has been disabled for this webinar. The Q&A feature does exist, so please enter any comments, suggestions, questions into the Q&A feature, and one of us will be back in touch, or we'll save a good question for verbal asking as the opportunity arises. We are very honored to have Tanya Haig, Jason Otkin, and Dennis Toddy with us today to discuss this project. So without any further ado, one further ado, this meeting is being recorded, and please be aware that any questions that we might ask that might reference you could be in a recording that will be posted to the North Central Climate Collaborative website, northcentralclimate.org. And let's be honest, it's December 14th. By January 6th this year, you're going to have to give us a little extra time this go round. So without any ado other than that, I'll turn it over to Tanya to begin.
Thanks. Just the right amount of ado. So thanks everybody for joining us today to talk about Midwestern Specialty Crop Board's decision-making during drought. This project has been a collaborative effort led by the USDA Midwest Climate Hub, the University of Wisconsin, and the National Drought Mitigation Center. It was funded through the NOAA program in support of the National Integrated Drought Information System. So Dennis is going to kick us off by introducing the idea of the decision calendar and the needs that it meets. And then I'm going to spend some time describing how we went about developing decision calendars and what we learned in the process. And then Jason Otkin is going to kind of wrap up with talk about matching drought information with grower needs. So we hope to have some time at the end for questions and discussion.
Tanya?
So please feel free to, yeah.
Yep. Could you reposition your phone? We're hearing that the audio is a little choppy.
Sorry about that. Hopefully this will be a little better. I'll try to, by the time it gets back to me, I'll try to make it better. Okay,
that's a little louder. Yeah.
Okay, I'll hand this off to Dennis then.
Okay, thanks, Tanya. Let's go ahead and go to the next slide. Appreciate the handoff here. So the first part of what I'm going to talk about is to give us a little bit of background of why we're dealing with specialty crops and in the Midwest. You know, in the Midwest, who's concerned about specialty crops? We grow corn and soybeans, right? Well, we do, but there are concentrations and distributed areas of specialty crops all around the Midwest. With some of the especially the map on the right-hand side here shows from a vegetable standpoint, what percent of the U.S. vegetable crop is grown in various states. Obviously, California has a large portion, but we have portions that, and in several of the Midwestern states that are along here. So that's especially up around the Great Lakes, very high, higher density of areas of production, partially from a climate standpoint and a soil standpoint. The soils are appropriate for some of the other issues. We also have concentrations of things like pumpkins in central Illinois. Trent Ford can talk to you about pumpkins ad nauseum. So we do have these areas, and they have a high economic value. Now, another reason we are doing this is because my predecessor, Jerry Hatfield, had started some work with specialty crops and handed this off to me. And there are a number of different issues related to specialty crops, which are too numerous to talk about, but there is a higher level of risk. And even specialty crop growers will say that. We know that we're doing something riskier in what we're doing that doesn't have quite the protection that corn and soybeans do, but they have but there is a markets for several of these things. There are other levels of risk, including weather and climate and weather-derived kinds of things like increased disease risk. There are labor issues because you A lot of these crops you can't necessarily run a combine through, so you have to get labor associated with these. There's issues with that, markets, insurance, all kinds of different things related to risk. So there is a higher decision-making need, but then there are issues related to trying to develop information for these small areas and small users. Not all small, but more, not as ubiquitous as corn and soybeans. So that's part of the background of that combination. And then there came a third part of this, an interest in developing more drought information. That's where the National Drought Mitigation Center and NIDIS come into this equation. But there's also an issue that we have that when we're dealing with gathering information for the U.S. Drought Monitor, we get reports on the corn and soybeans. A couple of states like Michigan have a little bit more information on some of the specialty crops, but there are a lot of other places where we don't get much drought information back on how things are being impacted by drought. So trying to make more connections on this drought list overall. Okay, let's go ahead and go to the next slide. So what we're trying to do here is trying to come up with drought information. Like I was talking about, it's underused as a trigger. Drought is underused as a trigger for ag management decisions. A lot of decision managers don't know how to use that drought information. And then there's a lack of understanding by information providers how to inform key decisions. A lot of work has been done by the Drought Mitigation Center, like on rangeland, particularly how to help rangeland producers, ranchers understand how to make decisions related to drought. But we haven't had the time to develop inroads with a wider variety of crops, and especially when you're dealing with specialty crops, it's more specialized for the various crops, and you're dealing with smaller numbers of growers overall. But the other part about it too is that the people who are providing information sometimes don't understand when key decisions are being made. When are important points in this crop's growing cycle where water or other things come into play, and we really need to know more information about that, so that knowing that intense rainfalls, or in this case drought, is going to be much more of a problem. And just a reminder, the graphic down below, to say that drought is an important issue around our region. That shows the Midwest area, percent area of drought over since the life cycle of the U.S. Drought Monitor. Tanya, were you going to say something there?
Oh. No, and I accidentally clicked forward, so.
That's okay. That's
okay.
okay. No, okay. That's okay. I thought you were going to chime in. We are going to try to do that to each other a little bit, to chime in a little bit and do this kind of song and dance routine that we're going along here. Okay, a little bit more on decision calendars. For those of you that were familiar with the Useful to Usable project, this was one of the products of the Useful to Usable project, the Decision Vortex, that was developed by Gene Tockley and authors, that was tried to get at this idea of connecting decision calendars to information. Now, first, back on decision calendars, there's lots of different decision calendars out there already. Some of them are producers had, you plant, the first full moon after Easter or something like that. There's all kinds of those that are developed for one reason or another, that had, maybe some value or some guidance. We now know that there are other things that come into play that should be used, but so some relative decision calendars have been around, but there's more detailed ones, which this is an example of. This was trying to connect corn producers' decisions with what climate information was available at different times of the year to see when we had skill or information we could provide those producers towards making decisions. So that was one more detailed example of a decision calendar. And so, this is a general one, but then because we're dealing with drought in this one, part of what we're trying to do is, determining when specifically drought becomes more of a potential problem. So there are multiple outcomes from this that are quite good, but that's some of the overall issues. Okay, go on to the next slide. And I believe, okay, one more thing about what information can be embedded in a decision calendar. What can we get from it? A lot of details can be gathered in there or embedded in this. Who makes decisions, what types of decisions, and when. When is weather a concern? Obviously, there are different times of the year where Drought is usually a problem, but drought sometimes can actually be a positive thing. Like planting season this year, drought in the spring was actually a good thing because we were able to get that, to get crops in the field more readily. Impacts, what weather and climate variables can lead to consequences of decisions. Lots of other factors. So there's a great deal of information that can be embedded in a decision calendar, more than we're going to dive into today, but this gives you an idea of the overall background. Okay, I'm going to pause here and we're going to turn over to Tanya.
Okay, thanks, Dennis. And I apologize in advance, I'm on my phone. For some reason, my computer didn't want to play with WebEx sound today, so I hope you can hear me okay. My job in the presentation is to describe how we set about building decision calendars for a number of specialty crop systems in the Midwest. And I want to do this both so that you can understand the efforts behind the products, but also so that you might have a sense of one way to go about it if you're interested in doing this kind of work with other specific crops or in other sectors besides agriculture, for example. So our approach involves, we developed a stakeholder expert advisory committee. We conducted focus group interviews with specialty crop growers and advisors. We analyzed how existing drought monitoring tools meet the stated grower needs that we were hearing about. And then we used really an iterative process to develop the decision calendar and fact sheets that we'll share with you in this presentation. First, I really want to emphasize the stakeholder advisory committee. This committee not only provided the expertise that we needed on the cropping system that we studied, but they also helped us make connections and bring growers together for the focus group interviews. And then they came back after we had gathered the data and they helped us better understand the data that we gathered and represent it accurately in the resulting decision calendars. So I really can't shout out this group enough. We are extremely grateful to the Iowa Wine Growers Association, the Wisconsin Potato and Vegetable Growers Association, the Wisconsin State Cranberry Growers Association, extension specialists and educators in Iowa, Wisconsin, and Missouri, and individual growers who participated over the two-year project and process. So this stakeholder advisory committee, with their help, we met with specialty crop growers and advisors in 3 states, Wisconsin, Iowa, and Missouri. We conducted focus group interviews in the locations that are circled on the map in red there. And we ended up focusing on a number of specialty crops that have a great deal of economic importance in the Midwest. Potatoes and cranberries in Wisconsin, grapes and apples in Iowa, and mixed fruit and vegetable market garden systems in Missouri. Now, the purpose of these interviews was to work with growers to identify what are the key decisions and the timing of the decisions that growers are making during drought. And also then to investigate the types of drought monitoring information that could better inform their management decisions. So these 3 focus groups were held during February and March 2019. The last one, the Missouri one, actually took place like the same weekend, or the same week as the bomb cyclone in March. So there was a lot of climate going on. We engaged a total of about 28 interview participants. So what we learned came largely from that group. Each focus group interview lasted about 4 hours. They were half-day sessions. And what we did was, after a short presentation explaining what we were looking for, we led guided discussions using the set of questions that are listed on this slide. And we organized the discussions by season. So, for example, in the spring, what are your concerns? How does drought affect you? What information are you looking for? And then in the summer, kind of going through it in that way. And because 2 of the study areas we were doing the interviews in were actually coming out of very wet years, not dry, we did discuss management concerns related to both extremes. And of course, there are some interactions between wet years going into dry years as well. So it was very informative to do that, even though you'll find that the specific set of decision calendars that we're going to present are really focused on dry conditions. So then after working through the year's production issues, we did share a number of existing as well as sort of newer in development drought monitoring tools that could be used. And we wanted to share those examples so that we could get feedback from the participants. So we shared some maps of drought at various times, and we asked them how they interpreted that information, how the information would be used to inform those specific decisions that they had talked about, when they would need the information, how often they would need the information, and at what spatial resolution. And the result was a table full of data. And what we did with that table full of data was we tried to start making relationships. And we tried to depict the relationships between time of year, crop stages, decisions, drought conditions, and impacts by placing all of that data that we had gathered into these sort of visual, graphic, crop-specific decision calendars. You can see it starts with January over on the left and kind of works its way around. I shared this as the first draft. It's definitely not very pretty, but it helped us kind of work through the process. It helped our advisory committee take a look at what we had gathered, fact-check the information and relationships. It helped our project investigators connect decisions and information needs with and connect those with the types of drought monitoring tools that exist or that we could be developing in the future. So then this is the next iteration. Once our graphic design team at the NDMC got involved, we were able to produce a much more visually pleasing and understandable annual calendar for 4 Midwest specialty crops is what we ended up doing. Grapes, apples, cranberries, and potatoes grown under irrigation. So this is the resulting graphic for grape production. These are all available on the NDMC website. That's the link on the left, and we'll bring that up again later. You can see that each calendar has 4 rings in addition to the month. So on the outside in the dark green, we've got stages of crop development, and then working into the light green, management decisions. In the blue, drought concerns at that time of year, the month here, and then in this brown, dark brownish area, the outcomes and when those are observed. I'm going to zoom in on each of these so that we can look at the calendars in a little bit more detail. So hopefully you can see this a little bit better. For example, here is the January through June timeframe in grape production. And along the outside, you can see this is time of bud break, flower formation, and fruit set. And we've got a lot of decisions being made around planting, pruning, insect and disease control, thinning flower and fruit clusters. In the blue, we can see there are some drought concerns that are really just for young vines versus established ones. There are points as you read through here where dry conditions may be beneficial to crop outcomes. And as you read through, you'll also note that that growers are managing to optimize this year's yield while at the same time managing to keep the vines healthy and productive for the long term. And before we go on, I do want to make a note about this. This applies to all of the decision calendars. This project really took a broad look at the types of decisions that are being made and the timing to try to figure out how drought information is meeting these types of information needs. It's not going really in depth. So for example, any of these decisions, such as pest and disease management, is a really good example, would be investigated at a much more in-depth level to inform, for example, new tool developments that are specifically aimed at decisions along that. So I just wanted to clarify sort of what the goal of these are. So again, grape production later in the year, later in the summer and fall. Grape growers are interested in heat and precipitation for grape quality reasons. And they're also thinking ahead to drought's possible effects on next year's fruit buds and crops. So that's the second calendar that we looked at here is the Midwest apple production calendar during a drought year. Many similarities to grape production, some unique concerns. Zooming in to the January through June time period again, you can again see sometimes a year when some level of dryness is preferable to growers, such as pollination and during some disease periods. The decision calendar helps us identify this first 50 days when drought might impact the growth or size of this year's fruit, as well as later in the year identify when drought is more likely to affect fruit quality. Again, unlike with most annual crops, we've got concerns not just with the current year's crops, but also with long-term plant health and future crops as well. So here's the decision calendar for Wisconsin cranberry production during a drought year. Investigating cranberry production was very interesting, gave us an opportunity to explore some really unique crop decision seasonality and concerns compared to maybe what we're used to in the Midwest. So again, we'll zoom into that January through June timeframe. Some of you may be more familiar with cranberry production than others. Cranberry production requires flooding for different purposes at different times of the year, and also largely depends upon irrigation. So hydrologic water supplies are going to be very important to growers' decisions, and maybe more important sometimes a year than precipitation directly. But we learned from growers that while that's true, dry conditions and particularly hot, dry, windy conditions can have a very negative effect on plants and crop health, both in the spring when plants can be desiccated and injured, as well as in the summer when hot and dry conditions can make plants susceptible to insect and disease damage, including scald, which affects yield and fruit quality. So growers are doing a lot of management during this time to strategically protect plant roots and accomplish pest control, and they're using flooding to some degree. So this is one case where precipitation-driven drought and hydrologic-driven drought might sort of have the potential to compound with each other. And then in the July through December part of this decision calendar, you can see cranberries are harvested later than apples or grapes. So late summer and fall drought may have more of an impact on this crop. These are months when, again, growers are concerned that water be available for flooding the fields for harvest. Low water volumes in reservoirs and streams, along with warmer than normal summer temperatures, can result in warm water temperatures, which can cause vine stress, and managers will be thinking about changing the speed and timing of their harvest to adapt to that. And then one more crop I wanted to touch on before I hand things over to Jason. We looked at one annual crop in this project, and that's irrigated potato production that is economically important specifically in Wisconsin. Potatoes, of course, are grown throughout the Midwest, but we focus on irrigated commercial systems in the Central Sands region of Wisconsin. And this system has been very ideal for potatoes. It depends upon the availability of irrigation resources. And so one major concern that you can see, and we'll zoom in on this in the December through January time period, is the replenishment of the aquifer, the gravel shallow aquifer in the region over the winter months. So sort of December, January, February, these are times of critical aquifer recharge. And this is important not only for potato growers who are looking ahead into the season for irrigation, but it also affects area lake and river levels. And that's bringing many other stakeholders to the table as well. So for these reasons and many others, potato growers in the region are invested in conserving aquifer resources. But they do rely heavily on irrigation on their sandy soils, and especially during drought conditions when all of this can be compounded. So really the working order and the efficiency of their irrigation equipment is critical. And there are some management things that they might do early in the year to make sure that their irrigation is ready to go if dry conditions are going to be faced later in the year. So then let's look again at the July through December time period. Again, efficient, non-clogged irrigation equipment becomes very important in the summer when tubers are bulking and high daily evapotranspiration rates may easily exceed irrigation capacity. Managers are really focused on decisions about the speed of their irrigation pivot, and they really want to know how ET rates and soil moisture across their fields are changing at a fairly high spatial resolution and as close to real time as possible. So irrigated potatoes are probably the most like commercial corn and soybeans as far as having a commercial interest in providing monitoring information. But growers really indicated that there's plenty of room for improvement in monitoring and prediction that might help them make the most efficient use of irrigation water and meet both their production goals but also conservation goals. Okay, so these are some brief examples. We can come back and look at these. If you have any questions, we can come back and look at these slides. Some brief examples of what we learned about the annual decision cycles of various specialty crops and how drought can be a concern. The next step then was working with climate scientists to match those needs with existing tools and then identifying any gaps that exist. And I'm going to turn it over to Jason for that part of the discussion.
All right, thank you, Tanya. Thank you, Dennis, for a very excellent summary of the decision calendars. So we're going to change topics now, and I'll spend the rest of this presentation discussing some of the weather, climate, and drought monitoring and forecasting needs for specialty crop growers, as well as some of the tools that are currently available to meet at least some of those needs. Now, as Tanya discussed in the previous slides, specialty crop growers need to make important tactical decisions throughout the year, while also making long-term strategic decisions that could affect the viability of their farming operations for years to come. Now, one of the things that became clear during our discussions was that specialty crop growers, they tend to fall through the cracks of existing federal crop insurance programs because those programs are really designed for the big commodity crops, such as corn and soybeans, or for livestock producers. Now, as both Dennis and Tanya mentioned earlier, this then puts some specialty crop growers at greater financial risk due to losses caused by, whether it be drought or other natural disasters, because they simply don't have the same level of governmental support that's provided to livestock and grain producers. Now, this then means that access to accurate weather, climate, and drought monitoring and forecasting information is very critical for them then when they're trying to make their tactical and strategic decisions. Next slide, please. Okay, so to help meet the needs of specialty crop growers, one of the things that we did then was to compile an inventory of weather, climate, and drought monitoring and also forecasting tools that are freely available for use from various websites. I'll mention here that existing tools that are available, they're typically not optimized for specialty crop growers. So there's definitely a clear need for additional research to be done in order to increase their utility for the specialty crop growers. There are still many valuable tools out there, though, that still can provide useful guidance when they're making their management decisions. So based on our conversations with the specialty crop growers within the Midwest region, then we developed fact sheets for several specialty crops that can then be used to help advisors and also the growers match their unique seasonal decision-making needs with the tools and resources that are currently available. We did this for several perennial fruit crops, annual vegetable crops, and also cranberries. And we organized these fact sheets based on different seasons. So in the next few slides, I'm going to provide a brief overview of the drought monitoring and forecasting tools that we listed in the fact sheets, and then how they can also be used during different parts of the year when making management decisions. So I'm only going to show the fact sheet for the annual vegetable crops, but I will make comments about the other specialty crops as I go along in these slides. So I'm going to start here with winter. Again, this is for the vegetable crops. During the cool season, farmers often rely on winter precipitation to replenish soil moisture and also to recharge aquifers and reservoir levels that will then be used for the next growing season. Now, adequate snowfall is very important within these northern regions because it helps to protect vines from desiccation and also from large temperature swings. And agricultural droughts, of course, they can emerge prior to the start of the growing season. So maps that depict how conditions compare to normal can help growers make preliminary decisions as to which crops and varieties they should plant during the springtime. So tools here on this slide, such as the U.S. Drought Monitor and also the Midwestern Regional Climate Center's Climate Watch, they can be very useful for this purpose, for kind of getting a head start on trying to decide what you should do for the next growing season. Next slide, please. Okay, so spring is a very busy season, of course. It's got tillage, planting, fertilization. There's a whole host of different activities that have to be done during the springtime. Soil temperature and soil moisture maps, such as those that are shown here, along with seasonal drought, rainfall, and temperature outlooks, they can be used to make final decisions regarding crop varieties, rotations, and when to actually plant the crops. Drought conditions during the spring can make it risky to plant new trees or vines because even if there is sufficient subsoil moisture, high temperatures and below normal rainfall can still damage sprouts and seedlings because they're unable to access subsoil moisture if it's still present at that time, of course. Drought conditions can develop very quickly during the spring and, of course, also during the summer when the evaporative demand is higher than normal, and this would be due to things like hot temperatures, sunny skies, low relative humidity, and strong winds. And when these types of weather patterns occur, and when they're accompanied then by little to no rainfall, this can then lead to something called flash drought. So flash drought is characterized by periods where vegetation health rapidly deteriorates over the course of several weeks. Next slide, please. Okay, so then during the summer, monitoring tools that alert growers to emerging drought conditions and vegetation stress are very important. There are several tools available that can help growers monitor soil moisture and evapotranspiration over daily to weekly timescales at larger spatial scales. Now, evapotranspiration and soil moisture are very important variables to monitor because they are more direct indicators of vegetation health than are things like just precipitation deficits by themselves. So, for example, evapotranspiration and soil moisture monitors, they can improve the efficiency of variable rate irrigation systems and also help growers conserve water when possible by protecting plant health and of course, also yields. Now, advancements in satellite imaging of the land surface during the past couple of decades have led to the development of several new tools that can be used to monitor evapotranspiration, two of which are listed here in the slide. So these include things like the evaporative stress index, or the ESI, which shows where moisture stress is occurring based on changes in evapotranspiration. And there's also another tool called Quick Dry, which combines satellite data with some other information about the land surface and about climate in order to depict areas that are undergoing rapid drought development. So both of these tools then can be very useful for trying to get an early warning for things like flash drought. Next slide, please. Okay, so then for perennial crops, drought has a major role in determining which pest and disease problems emerge during the growing season. Also how heavily fruit clusters need to be thinned, and how quickly the fruit itself ripens. Now, during the fall, perennial fruit growers monitor soil moisture after the fruit has been harvested, and they do this in order to ensure that sufficient moisture is available to support winter cover crop emergence and also its growth, and then to maintain the trees and vines during the winter. Soil moisture monitoring is also necessary for grass seeding, nutrient and pH management, and of course also for fall tillage in preparation for next year's tree plantings. So inadequate soil moisture, when combined with extreme cold and insufficient snow cover during the winter, this can actually result in root damage, to the fruit to the fruit trees, to the shrubs and vines. So it's important to try to prevent that if possible. Next slide, please. Okay, so finally, we also looked at climate decision support tools over annual to interannual timescales, because those can also be useful, again, for the longer term planning that producers might have to make. For example, perennial crop and cranberry growers, they make decisions that will affect their operations for many years to come. Such as choosing specific crops, specific varieties to plant. They also need to locate the crops for optimal health and productivity. And they also want to make sure that they can plant under climate conditions that allow the trees, the shrubs, and the vines to get off to a good start. So seasonal drought and climate outlooks, they provide growers potentially useful information about precipitation, temperature, soil moisture, and drought that could occur during the next month to maybe up to the next year. So this slide shows a couple examples of these outlooks that they're provided by the NOAA Climate Prediction Center and also by the USDA Midwest Climate Hub. In addition, long-range tools from the USDA that depict current and future cold hardiness zones for vegetation, as well as changes in precipitation and temperatures that could occur in the future. And those can also be very useful because they can help growers determine which trees, shrubs, or vines they should plant in order to make them most likely to be able to thrive under future climate conditions. Next slide, please. Okay, so in the last few slides here, what I want to do then is to show an example that demonstrates an experimental product that several of my colleagues at the U.S. Department of Agriculture have been working on during the past few years that could potentially be very useful for specialty crop growers. Now, one of the main challenges when using any of the tools that I described in the previous few slides is that their spatial resolution is simply insufficient. It's insufficient to represent the small scales over which specialty crops are often grown. Now that makes those other tools less useful for specialty crops because they can't properly represent moisture stress in those fields, nor can they represent potential changes in moisture stress across a given farm due to changes in things like soil types or just due to different crops. Now, the image on this slide, it shows how the amount of evapotranspiration varied across part of central Iowa. This was generated using data from the Landsat satellite and also a surface energy balance model. It's able to use that satellite data in order to estimate the amount of evapotranspiration that's given off by the surface each day, or at least when you get an overpass. Now, of importance for specialty crop growers is that this data is available at 100-foot resolution or 30-meter resolution. So this means that you are able to monitor moisture stress of a very fine spatial resolution across the entire field. But to demonstrate this more clearly, what I'm going to do the next two slides then is to zoom in on the smaller box that's located in the eastern portion of this domain in order to really give you a flavor or give you a better sense for what kind of resolution this data set can provide. Next slide, please. Okay, so on this slide then, what I'm showing is the total accumulated evapotranspiration that occurred within this smaller region. This is showing for each year from 2010 to 2014. Now, with these images, what they do is they represent the total amount of moisture that was evaporated from the land surface or transpired by vegetation during each of the growing seasons during these years. This is going from March 1st up till November 1st of each of those years. Now, dark green colors, they show locations and years that had higher evapotranspiration, whereas the yellow and red colors indicate locations that had less ET or less evapotranspiration. So I want to emphasize here that we're able to see differences in water usage at individual fields with this data. We can also see river valleys. They're indicated by the dark green colors. I can also see the drier upland areas, which are indicated by the yellow and orange colors. Now, one of the things that jumps out here when we look at these total growing season evapotranspiration maps was that the evapotranspiration was very low during the droughts of 2012 and 2013, whereas the conditions were much more favorable during the other years. Now, during all of these years, though, you can still see that there is a lot of spatial variability from one farm to the next across this region, and this does demonstrate why it can be very useful to use these high-resolution evapotranspiration data sets. Next slide, please. Okay, this is the final slide I'm going to show. Then, so to show the changes in stress more clearly, what we're looking at here is the moisture stress during a 4-week period that ends on August 4th of each of those years. Now, this was done by dividing the amount of the actual evapotranspiration that was estimated using the satellite data, and then dividing it by the potential evapotranspiration that's going to be a function of things like temperature, wind speeds, and sunshine. Now, in this case, then, the green colors indicate good conditions, whereas the yellow and red colors show locations that had a moisture stress. Now, with this depiction, then, it's immediately clear that 2012 was a very bad year, with widespread moisture stress, across this entire region. 2013 was a little bit better, but still quite dry. And then in the other years, especially 2014, had very favorable conditions during the middle of the summer. Now, I just want to emphasize again here, though, that there is still a lot of field scale availability during each of those years. So this does make the high resolution data that can be provided by the Landsat satellite and then by the retrieval algorithm to get that evapotranspiration data, it can make it very useful. So we do think that that could be a very useful tool for specialty crop growers once it becomes more mature. All right, so I'll hand it back to you, Tanya.
Yeah, sounds great. Thanks, Jason. Yeah, I think those last four slides really help demonstrate the point of there are some opportunities for some really good productive work, I think, with specialty crop growers and drought monitoring and prediction tools, as well as other climate information tools. So I just want to wrap up with, again, posting the link to the website. All of the decision calendars and the associated fact sheets are available at this link on the NDMC's website. You actually have to go here and then look for the project. It's not super hard to find, but you have to look for it. I believe it will also be up on the Midwest Climate Hub's website in the near future as well. All of the materials are available in versions to view online, but also versions that are optimized for printing. And we're really hoping that as you find them useful, that you will download them, that you'll use them in presentations, or that you'll print them out and hand them out wherever it seems helpful to you. We wanted to try to create some outputs that could really be helpful in education and outreach. If you're interested in linking to the information, using it in your own websites, please do be in touch if you have questions about it. Of course, we're interested in expanding the work. We'd always like to learn more about drought impacts to different crops, expanding the range of crops and represented regions that are represented here. So please do be in touch if you have an interest. And then very finally, if you do have an interest, we wanted to wrap up with just a few recommendations for building and using decision calendars based on our experience. And we've kind of touched on all of these things going through. We've already stressed the importance of the stakeholder advisory group, but I wanted to just say that again here. We found it really helpful to share some other examples of decision calendars during those focus groups to give people a sense of the kind of information that we're looking for. The concept didn't necessarily resonate right away with folks, but then we found by the end of the focus group sessions, people really found it interesting and valuable in the end. We'd like to stress the two-way nature of communication, that growers are the experts providing us with the information about their decision-making time frames, their needs, and that scientists, it's important for the scientists to be there to listen and then to help share information, identifying the capabilities of climate and drought information. Along the same lines, we found that the process of developing the decision calendars and developing those fact sheets with the climate information was really an iterative communication process among the researchers, the growers, and the stakeholder advisors. So I think overall, I think the process inspired new thoughts about additional work that can be done in the future. And I hope it gives you some ideas for some work that could be done as well. So with that, we do have a little bit of time left for some questions. We'd like to thank you again for joining us today. Want to open up the conversation. I'm happy to flip back through. As it's not super responsive, but I'm happy to flip back through to any of the fact sheets or decision calendars if you want to refer back to them. So I'll turn it back to Hans for questions, and thank you.
Yes, please do enter your questions into the question and answer box. There's one question that hasn't been answered at this moment, so I'll ask that and then I'll open the poll for everybody. Did you find any growers in the course of your research that use soil moisture sensors for irrigation management? And if you did, is it possible to correlate soil moisture with any of the drought maps or calendars?
Great question that I'm guessing either Dennis or Jason can weigh in more on. I think that work was, probably the potato growers were most likely, they were probably the most, they had the most technology available to them. And I believe, and since it's such an irrigation intensive area, there have been investments in soil moisture monitors, but Jason can speak to the fact that I think there was a lot of interest in needing maybe some of the remote sensing data to verify or to fill in some holes there. A lot of the other growers that we worked with were maybe growing more for more local markets, were a little bit smaller or not quite as high tech and probably didn't have quite as much of that technology on their own. Anything you'd want to add to that, either Jason or Dennis?
Yeah, really nothing more to add on my standpoint. I didn't get to all the groups like you did.
Mm-hmm. Jason, any thoughts? I know that would have been something you would have been paying a lot of attention to, is the use of soil moisture monitors and how that compares to the remote sensing data, the data going into the drought monitor, anything like that. Do we still have Jason? Jason, you're muted if you are trying to say anything. If not, we can go on.
Let me provide one follow-up. I mean, that is one of the interesting things when you're talking about working with specialty crop producers is a lot of these folks have other supplemental systems to make sure that water is not limited. So minor droughts tend to be less of an issue for these folks. It's when you get into more serious drought conditions or prolonged drought conditions where other water supplies become limited. Like I have heard a story in Iowa this year of a producer who pumped his well dry trying to maintain specialty crops. So, those are the kinds of things that we're dealing with for trying to help people make these decisions.
Yeah, I think you're right. Yeah, I mean, we didn't really talk a lot about product quality today, but for all of these specialty crop products that we looked at, with quality being as much of a factor as yield or quantity, they really don't have a lot of room for error in water use. I think you're right. And that also just made me think back to, I think it was the Iowa focus group. There was also really a discussion about how growers who maybe are also growing corn and soybeans are maybe tied into a lot of the emerging commercial weather and climate monitoring systems that are being provided as packages through their inputs, whereas a lot of smaller growers or growers who aren't already also growing corn and soybeans, that kind of cropping system, are kind of left out in the cold as far as having as much monitoring information available for them and decision tools.
There is, what Tanya brought up, the quality issue. All right, Jay, Tons, is there another question, or should I
We
go
have all
ahead?
kinds of questions, yo.
Oh, go.
Okay. Let's. All right. High-res evapotranspiration maps. Are those available for the public to view in any way, shape, or form? Will they be in the future? And the question asker says, having high-res evapotranspiration maps would be useful to kind of overlay with weather climate forecast probability maps. So do those exist? Are they available?
It's definitely a Jason question.
Yeah, it is.
I'll try to answer this one. I'm having a lot of web issues right now, so I didn't hear all the question, but I think it had the high resolution ET data. The short answer is of coming available. This is something that I personally am not working on closely. This is with my colleagues at the USDA that's working on it. It's something that I'm trying to scale up to a much larger data set. Like, we have to keep in mind that if we're looking at 100-foot resolution, that's a lot of data. It requires very different ways of handling the data. So what they've been working on right now is individual domains. So as you know, the domain that I showed was what we call the Ames, Iowa domain, focused on central Iowa. But eventually that will be scaled up to larger areas. I know that they are working on a different project that's Open ET. I think that data might be posted on the Amazon web server, but I'm not overly familiar with it. But I definitely think that the momentum is definitely moving in that direction of getting this available, in much more real time and much more convenient format for people.
What else you got, Hans?
Okay, in your, analysis of currently available data, has anything like this been done on the West Coast?
Ooh, that's a good question. I don't know. I don't know the answer to that question. Dennis might. I'm going to jump in and say that the Northwest USDA Climate Hub has done some work with specialty crop growers specifically, and developing some long-term decision tools around the appropriateness for different locations for different specialty crops. But I don't know if there's anybody out there doing work that exactly looks like some of this. Dennis, do you know?
Yeah, I don't think anyone's doing exactly this, but I know there are people working with the decision making about, regarding drought, water access, those sorts of things. Definitely the wine growers. I think we've had some work in our lab with the wine growers, and I would assume with the last several years of water issues that this is becoming more of a decision, more active work on this decision and water use across California.
Mm-hmm. Sorry, we don't know more. I'd be happy to help follow up with whoever the questioner is.
Okay. I guess one other question outstanding at the moment. Does any of this data that's been generated help farmers in applications for crop insurance?
Sorry, I missed that, Hans. What was it?
So this data that's generated is something of a risk assessment too, right? What time of year you're involving, what kind of risk.
Yeah.
So it plays into crop insurance a little bit. So the question is, has the data you've generated helped farmers to apply for crop insurance?
Not for applying for crop insurance specifically. There is work from RMA with more improving. I talk good. improving access to crop insurance for specialty crop users. Okay, not a specialty area of mine, but an issue of the hubs. But I know that there is work being done to cover some of those issues with those folks. But you are right that this is very interesting and something that we should evaluate a bit more to see if we can share it with more actively with other parts of USDA. I like that idea.
Mm-hmm.
That catches us up with the question and answer. If anyone has one last question, please let us know. Otherwise, any closing thoughts from the group?
Tanya, can I go back to the one comment I was going to make before we went to the questions? There is an interesting aspect that we've not talked about drought and specialty crops. Is there's sometimes some counter-cyclical impact of drought, in that while, like this summer, there was some reduced productivity of certain specialty crops. I believe it was apples. The intensity of flavor was reported to be better in apples. Or Hans, the session we did down in Indiana, where a guy was a watermelon grower was talking about disease risk, and he said they loved 2012 because they had plenty of water and they had zero disease risk. So the impact of drought is not always a negative. I'm not advocating drought, but it sometimes there are positives that can happen.
Yes, absolutely. Yeah, I think we definitely heard that in many of the sessions. And again, coming out of really wet years in both in Wisconsin and Iowa, when we were out talking to folks, there's probably a lot more focus on it can be harder, probably wet conditions and dry conditions for a lot of these crops. For the project, we had a specific task that we needed to accomplish, but there's clearly a lot of work needed in managing information to help manage wet conditions, and probably something that needs more attention is what happens as we have more wet springs and dry summers in the Midwest too. So I know we're right at 2:00, Hans. So I mean, as far as final comments, I'll just say I know Jason just messaged me. He's having some network connectivity problems. So I'll just say on behalf of the team of this project, it's been really interesting for us, and I think really just starts to dive under the surface of work that could be done that could really help make better connections between agricultural decision making and the kind of information that climate scientists and others are starting to be able to produce. So I think there's a lot more work to be done, but we really enjoyed this part of it. Working with the growers is always really educational and really fun.
And we've got Jason back for any last comment there. If Jason, your issues have resolved themselves, please do let us know.
Yep, I'm back now. I don't know what happened there, but if anybody has any questions, just feel free to send me an email too.
Yeah. Oh yeah, let me go back to that just at the very end. All right, thanks, Hans.
All right, thank you. We'll end on this slide, and I bid everyone adieu to follow up with the word of the day.
Thank you.
Thanks all.